Can you hear me? Can you hear me? I'm starting the class now. Can you hear me? Please, if you can hear me, let me know you can. Perfect. Can you hear me now? Okay, good. Favor, you said yes, you can. All right, great. So, without wasting time, I think we'll continue, and then if others, when they come online, they will join us. All right. So let me just let them know one more time that we are live. Let me share the link. Some of them are finding it a bit difficult to. All right, all right, all right. Tonight we are looking at a topic, and whatever topic I discuss now, I will not go over it again. Any topic I discuss now, I won't go over it again. Uh, may I know who are the people that are online? Who are the people connected? Type your name in the comment section if you are connected. Okay, I can see three people now. All right, let's do that quickly. If you are connected and you can hear me, you can type your name in the comments. Waiting for that. Okay, good. I'm seeing some responses. Okay, David Alpha, I can see David, I can see Favor. All right, so let's go ahead. Now, today we'll be talking about heat transfer in physics. Heat transfer. I believe you all can hear me, and you can see my video clearly. You can see my screen, or you can see me, anyone. So let's talk about heat transfer. So when we are talking about heat transfer, we are talking about um, how heat can be moved, heat energy can be transferred from one source to another. How heat energy can be transferred from one source to another. Okay, I think I will prefer to, yeah. So now when we say heat is being transferred from one source to another, let me give you an example. The reason why you cook, when you are cooking, the reason why you have your pot on the fire and then your food is inside that pot, and your food gets done, is because it has been transferred from the stove to the pot, and from the pot to the food. Therefore, the food gets done because of the heat. So today we are going to understand how heat can be transferred. So the first thing you need to know is that heat can be generated from a source, and it can now be transferred to another point from where it was originally generated. Now, there are three major method of heat transfer. I'll quickly run through those three methods one after the other. I'll give you some important facts about each of them, and then we take it up from there. The first one is conduction. It can be transferred by conduction. If you can hear me clearly, can you type conduction? Conduction is from the word conductor, Conduction. Type it in the comment section. Let me know you can hear me. The first method of heat transfer is conduction. Type conduction. Let me see it in the comment section. Okay, good. Perfect. David can hear me loud and clear. So when we talk about conduction, conduction is a kind of heat transfer that involves the use of a conductor. Okay, Darian, you are on the call. You're welcome. So you need a conductor that will conduct the heat from the source to where you need that heat. So let me give you an example. If I have a spoon, a metallic spoon inside a pot, if I have a metallic spoon inside a pot, and then I put the pot on the fire and cooking, and then I quickly rush out and I return after some minutes and I grab that spoon, what will happen? You will notice that the spoon will now be very hot. So how come the spoon is now very hot? The reason is because it has been transferred from the stove to the pot and then to the metallic spoon, and that is why I can now feel the heat. And so that is heat transfer by conduction. So heat transfer by conduction involves a material medium. The material is that, the material is a conductor. It has to be a metallic material that can conduct heat or electricity. When we say conduct, conduct means a material that can allow the passage of heat or electricity through it. So when we say conductor of heat, those are materials that allow heat to pass through them. Okay, they are metals. So that spoon is a conductor. So simply put, conduction is the transfer of heat through a material medium, and that material medium has to be a conductor, and there has to be a contact between that material medium and the source of heat. So it's that contact that ensures that the heat flows. Now let me read one or two facts that you can put down here. Conduction is a transfer of heat from one part of the body to another part without the actual movement of any part of the body. So you are not moving the part of that body. What you are only doing is there's a contact between the conductor and the source of it. No actual movement. If one end of a metal rod is dipped into a hot liquid, like I explained, the other part of the metal rod will become hot. So it has been transferred through that metal rod. Is that okay? So the metal rod is a conductor. The opposite is insulator. Insulator are materials, or insulators are materials that will not allow heat to pass through them, while conductors are materials that allow heat to pass through them. So that is conduction. Now there are a few other things you need to know about conduction. The molecules at the heated end acquire more energy and they vibrate faster. So because they vibrate, and you remember, according to atomic theory of matter, matter is made up of tiny particles which are constantly in motion. All right, they are constantly in motion, and because they are constantly in motion, when there is increase in temperature, their kinetic energy will increase. The kinetic energy is the energy possessed by a body in motion. So, but when you now add heat, you apply heat to any material, the kinetic energy of the particles will increase, bringing about expansion. We spoke about all of that when we're dealing with expansion of materials. So now that is what will now make that conduction to happen. So there is movement of electrons or charges from that heated point now begins to move, and then it flows to the other part of the material. Although conduction occurs in solids, liquid and gases, metals are by far the best heat conductors, while gases are generally poor conductors. So liquid and gases are poor conductor. Water is a conductor but is a poor conductor. So, and we have insulators. Insulators do not allow heat to pass through them at all. All right. Then heat cannot be conducted through a vacuum under conduction. So let's talk about convection. So convection is the other type of heat transfer. Convection is spelled Convection. Convection is the transfer of heat, right, through the movement of the material. So there is a movement of the material, the hot material. Let me give you an example. You want to take hot tea in the morning. If you want to take hot tea, you put your tea, the powdered tea and the milk, you put it in a cup. Then you need to get a cup of water or a kettle of hot water. Okay, yes, convection. That's correct, David. Dubu, yes. You pour the hot water into the glass or into your mug that contains the tea, and then you have hot tea in your hands. How were you able to make that tea hot? By the movement of the water molecule, by pouring the hot water into the mug. You were able to get what? You were able to get the tea to become hot. Is that okay? You were able to get the tea to become hot. So that is heat transfer by convection, by the flow. So it's usually the movement or the transfer of heat through a fluid that flows. That fluid is the material medium, but it flows by the flowing of that material. So the hot water flows into the cup and then I've transferred it to the cup. So that is convection. Let me give you one or two other points about convection. One or two other points about convection. Okay, now for convection is the transfer of heat from a hotter region of a fluid. Can you see fluid now? To a colder region through the actual motion of the fluid. Actual motion of the fluid. Take note of those parts. For the conductor, there was no motion. There was no movement of the material medium. There was only contact. All right? Contact, and there is a conductor that is involved. But for convection, there is actual movement of the medium, of the material, of the fluid, the hot fluid. There is actual movement. Also, in natural convection, which occurs, for instance, when water is being heated on a stove, I've explained that. So the cold, dense water moves down. We have discussed that. So that is convection. Convection cannot occur in a vacuum. Remember, we said conduction cannot occur in a vacuum. Convection cannot also occur in a vacuum. There has to be movement of the fluid in convection. There has to be a contact with a conductor in conduction. While the last one is radiation. This radiation is the movement of heat through a vacuum. There is no material medium needed. There is no fluid that is flowing. There is no actual movement of the material medium. Is that okay? But you can feel the heat. For example, if you stay close to a bakery, if you stay close to a bakery or a oven in a bakery, you will be feeling the warmth, the heat. In fact, if you enter into a bakery, you will feel the hot, the temperature is very high. Why? Because there is a radiation. The heat is radiating from the oven to every the surrounding of that oven, all right, or the bakery. The same thing applies the sun rays. So this is one major question that comes out. They will ask you, how does the sun, how do you feel the warmth of the sun? The sun is staying thousands, hundreds of thousands of miles away from the earth. However, we can still feel the heat of the sun, and that is by radiation. There is a vacuum, there is a space, the space between the sun and the earth. You don't need to put a material medium to be able to access the heat from the sun. It is through ultraviolet radiation of the sun. So that is called radiation. So those are the three major methods of heat transfer. Now we are going to look at let's look at a few things. Radiation is transfer of heat between two bodies by means of electromagnetic waves. Take note of electromagnetic waves. All right. This mode of heat transfer does not require a material medium. That is, it can be radiated through a vacuum, as evidently occurs when the sun's heat is radiated through the space to the earth. Spoken about the. Now, all surfaces emit energy in form of electromagnetic waves. It is radiated as electromagnetic waves with wavelengths which are little longer than that of the light. The intensity of heat radiated by a surface increases with. So, what are the things that determine the intensity of heat radiated? Number one, the area of the surface. The area of the surface. So, the larger the surface that is emitting the heat, the more, all right, the radiation of heat, then the absolute temperature of the surface. Like I said, oven. If you look at a very big oven, metallic oven, and you look at a small oven, they will not radiate the same amount of heat. So that is surface area, and then that has to do with the size. Okay, the surface area, those are the area of the surface, and of course the absolute temperature. Now let's talk about application of heat transfer. In this application of heat transfer, how many of us have seen a vacuum flask before? You have seen a flask before. That's a water flask, water heater flask that they use maybe at home for a nursing mother that wants to use hot water for the baby. They pour it into a vacuum flask. So in your exam, they can draw the vacuum flask and ask you what is the application of heat transfer in a vacuum flask. Number one, if you look at the vacuum flask, you see that it has a plastic covering. The outer coating is plastic. It has a cork on the head, very thick plastic on the head. All right. And then, so each of these, they have their function. That covering of the head, the cork, all right, is helping to reduce heat loss by conduction and convection. They can ask you conduction and convection. Why is it conduction and convection? Conduction because it is a plastic, it's not a conductor of heat. If you pour that hot water into a stainless steel flask and you just cover it, or into a stainless steel cup and you cover it, you will see that after some minutes the water will become cold. Why? Because that stainless material, that stainless cup is a conductor. The cap is a conductor. So because it's a conductor, it will conduct it away from the water. The water will become cold. But as we are using a vacuum flask with a cork that is a plastic, that cork is not a conductor. So the heat cannot flow out by conduction from that cork. That is one. So it's reducing heat loss by conduction. It is also reducing heat loss by convection. How? You know, the water is boiled water, so vapor is coming out of it. That vapor is water, but in gaseous state, and that is convection. So it will reduce, it will not allow the water vapor to leave. That is reducing heat loss by convection. So we have been able to reduce heat loss by convection. We've been able to reduce heat loss by conduction. Then the plastic on the body of the thermoflask, the plastic on the body is also helping to reduce heat loss by conduction. Now, inside the thermos flask, if you check it, there is a silver lining inside, is a silver coating. The silver coat inside the flask. This silver coating will help to reduce heat loss by radiation. Take note, they will ask you to reduce this heat loss by radiation. That's the silver coating inside. And of course, there's also a glass inside the material. That glass will not conduct, is not a good conductor of heat, so it will also help to reduce heat loss by conduction. So those are the three or the parts of a thermoflask and how they help to actually reduce heat loss. Now, let's take note of these other applications of heat transfer. Number one, cooking pots are made of metals. I've spoken about cooking pots today, that your cooking pot, all right, it's a conductor. and that is why it can conduct heat from the stove to your food and get the food done. Let me give you this illustration. All right, your mom tells you to boil fish or boil meat, and you put everything on the stove, and you put your condiments, you cover it, and you put it on the fire, and you quickly dash to the sitting room to watch Telemundo or to watch Super Story, or for the guys to watch football, Arsenal, Chelsea. Are you with me? Then you now forget that you placed your meat on the fire, and then after a while you've been carried away by the movie you are watching, then suddenly you just started perceiving burnt offering. You know the meaning of burnt offering? You start perceiving that the food on the fire is burning, and then you just run. You run fast. Hey, I have to go and rescue this meat on the fire. And because of the zeal, okay, you just get to the kitchen and you just grab the pot, bah, because you want to rescue the fire, so that, or you want to rescue the meat from the fire so it doesn't become a burnt offering, which you have already done already. So you grab the pot, and the moment you grab the pot, what will happen? You will remember that, yeah, it's hurts your hand badly. You drop it immediately, you look for a rag or something, then you put it in your hand, then you eventually rescue the meat. Now, yes, burnt offering. So that means you have succeeded in cooking burnt offering. Now, that feeling you had in your hand is heat transfer. It has been transferred from the pot to your hands. That is heat transfer by conduction. Why conduction? There was a contact. You held the pot, all right? So there was a transfer of heat. That's conduction. Are we together? Another illustration is, if I give you a metallic rod, and I tell you put it into the stove. If I ask you to put it in a stove that has fire, and I said, as a serious student, make sure this rod does not leave the fire. And because you are an obedient student like David, you put the rod inside the fire, and you hold it like that. And then at the beginning it was cold, but at some point you will now begin to feel that the rod is now becoming hot. You remove one hand, you put the other hand, and then you begin to change it. Yeah, but because you are an obedient student, you hold it. At a point, you won't know when you will just drop it. And you see, you will not be able to hold it again. Why? Because the heat has been transferred from the stove to your hand through that material. But if it is a broomstick I give you, and I tell you, hold this end of the broomstick, put it inside the stove, and make sure it does not leave the fire. You put it in the stove and you hold it there. And because you are a serious student, you are a very obedient student, okay, you keep it in the fire. As the wood is burning, as the broom is burning at the other end, you don't remove it from the fire. You keep pushing it into the fire because you are an obedient student. You keep pushing it. Eventually, as the broom is getting burnt, and you are getting closer, at the end, you just put your hand inside the fire. Abi, because you are an obedient student. Is that not? You put your hand in. So that wood in material, or that broomstick burnt because it is not a conductor. Are you with me? It's not a conductor, so it was destroyed. But the rod, you didn't need to move from one spot to feel the heat because it's a conductor. I hope that is clear. So that is the difference between a conductor and an insulator. So the non-metallic material is an insulator. Now look at this. Another application, the engine of an automobile is cooled. Please take note. These are questions they can ask you. The engine of a car, why do they pour water into the radiator of the engine of a car? Why do they always pour cold water? They pour water so that there can be reduction of heat by convection. You will see that when they pour the cold water, after a while, the water becomes very hot. It becomes hot water because that cold water has to run through the engine and cool off the heat in the engine. So the engine of an automobile is cooled by convection, in which cold water stored in the radiator is circulated to the hot part of the engine where heat is removed. So take note of that convection. Are we together? Then a fan continuously blow colder air into the radiator to cool the water inside. Then you have a thermos flask, which is what I've discussed. A flask is used to keep hot liquids from cooling down or cold liquids from getting warm. How? It consists of a double-walled vessel with a vacuum between the walls. So if you look at that thermos flask, it has double wall. The outside, which is the plastic, then the inner one, which is glass. But there is a space, there's a vacuum between the two. And usually they use foam to just pad that inside so that the glass will not get broken easily. So why are we putting the space? It consists of a double-walled vessel with a vacuum between the walls. The surfaces on either side of the vacuum are silvered. Remember I mentioned silver coated, and the vessel is covered with a cork of low conductivity on the top. When hot liquid is placed in the vessel, its loss is limited as number one. The vacuum prevents heat loss by conduction and convection. You see, I've explained that earlier, that the cup on the head reduces heat loss by conduction and convection. The slippery surfaces limit heat flow by radiation, exactly what I said. Then the cork limits heat flow by conduction. Heat flow by conduction, the body. Now, that brings us to the end of heat transfer. Now, let me quickly talk about molecular structure of matter. Now, there are three states of matter. There is the solid, the liquid, and the gaseous state. The solid, the liquid, gaseous state. Now, before we continue, if you have a question, please ask the question before we enter into the molecular theory of matter. Any question? Please ask your questions now. All right, so in the absence of questions, let us continue. In the absence of questions, let us continue. Let us continue. So the next thing we are talking about the three states of matter. You have the solid, the liquid, and the gas. So we'll be looking at how does these materials, what is the kind of force of attraction that exists between their components? What kind of materials make up the solid, the liquid, and the gas? All right. Is the force of attraction, is it very, very weak force or very tight? Are the particles tightly packed together or loosely packed, and all of that? So when we talk about matter is made up of tiny particles called molecules, which are in a continuous state of motion. I have discussed that at the beginning, and I told you with increased temperature, the kinetic energy of these materials will increase and they begin to move faster, bringing about expansion. Now, in solids, the molecules are number one. In solids, molecules are arranged in regular patterns. You can write that down. In solids, molecules are arranged in regular pattern for solids. Then they are tightly packed together. The molecules of solids are tightly packed together. The molecules of solids are tightly packed together. All right. Then I hope you can still hear me. Please, if you can hear me, let me know you can hear me. If you can hear me, let me know you can hear me. Oh, good, 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 good. All right, let's continue. Now, then they are held together by strong forces of attraction called coercive forces. Please, in your exams, they can ask you to differentiate between a coercive force and adhesive. Cohesive and adhesive. So I will address that now. So these molecules or particles of solid, they are held together by coercive force. So when you say cohesive, cohesive is from the word coherent. If I say they are working coherently, that means they are working together. They are members of the same team. They are working together. So if I say this choir, they sing coherently, or they are coherent, or they are cohesive, that means all of them are singing, but they sing together. So they are all members of the same choir. So you use cohesive for particles of the same kind. All right. That the force of attraction between similar particles, bringing them together, is what you call cohesive force. While adhesive is the force of attraction between two dissimilar or two non-similar materials that are being joined together. Let me give you an example. If you look at water and glass, if you pour water into a glass cup, if you pour the water out of a glass cup and the glass is empty, If you look at the glass cup, you will see water molecules are attached on the inside in the body of the glass. Now they will ask you, what is the force of attraction that keeps the water molecule attached to the glass? The force of attraction that keeps the water molecule attached to the glass is what you call adhesive force. Because water and the glass, are they of the same type? Are they similar? No. Water is liquid, the glass is solid. So because they are not of the same type, you can't say cohesion, it is adhesion. But if it is water to water, if you pour water, you see that the water molecules are connected together. So the water molecules are connected together by cohesive force, all right? While water connected to glass is by adhesive force. I hope that is clear to everybody. So solid matter, their molecules are connected, are tightly packed together by a strong cohesive force. Is that okay? Now, another thing about the solid is that they are not free to move about but merely vibrate about their main position. So particles of solids, they are not, they are closely, tightly packed together. So they cannot move, they cannot be separated so easily. I hope that is clear. Now, before I continue, okay, let's continue. Let's continue. Number two, in liquid, if you look at liquid, they please can you still hear me? Can you still hear me? If you can hear me, let me know you can hear me. Uh, let me do a little disconnection here. Can you hear me? Please, if you can hear me, type it in the comment section that you can hear. Okay, good, good. Give me a moment. Okay, good. Okay, good. All right, so we'll continue shortly. All right, so I believe you can still hear me. Please, if at any point in this video you can't hear me, you let me know ASAP. Okay. Now, in liquids, let me talk about liquids. Number one, the force of attraction of the molecules is weak. Thank you. Is not as strong as that of the solid. So there are weaker force of attraction. It's not as strong as that of the solid. The particles are not tightly packed, they are loosely packed. Is that okay? Their particles are loosely packed. Then another thing about solid is that in terms of compressibility, can you compress solid? You can't compress it. Are you with me? You can't compress it. But for liquid, it's slightly compressible. If you pour water in a balloon and you press it, you can still compress it to a level. Even your sachet water, you can press it a bit. So it's to a level compressible. Another difference is that the solid has a fixed shape. Liquid form the shape of their container. So if you pour liquid into a keg now, it will form the shape of the keg. You don't have a fixed shape. Is that okay? So let's talk more about liquid. The molecules are not arranged in any regular pattern. The molecules are not arranged in regular pattern. Molecules are able to slide past one another. They can slide over each other. Then the molecules, the cohesive forces between molecules, though present, are not as strong as solid. There's a cohesive force. Remember, I told you cohesive force means a force between two similar molecules. So there's a cohesive force between liquids, but it's not that strong. Then you have molecules move at different speeds. Some of the faster molecules escape from the surface of the liquid, giving rise to evaporation. That's evaporation. While in gases, the force of attraction of the molecule is very weak. Very weak force of attraction. The particles are very widely far apart. All right. Then it is highly compressible. That is why you have compressed natural gas, which is called CNG. You can compress gas into a liquid. Is that okay? Then of course it forms it does not have a shape. If you open the container, it escapes from the container. So gases, the molecules are about rapidly and randomly. They move about rapidly and randomly. The molecules move at different speeds. Then The molecules are farther apart than in solids or liquid. I've said that cohesive forces are very small. The forces are very small. Solids are rigid, have fixed shapes and volume, generally have high densities than liquids and gases. While for a liquid has a definite volume but no definite shape. I repeat that, definite volume but no definite shape. It takes on the shape of the container. I've said that. Then the gas has no definite volume or shape. It will expand to fill the container. So that is that about the state of matter. Now, at this point, I want to take questions. We have discussed heat transfer. We have discussed nature of matter. I want to take questions before we proceed. Any question? Okay, somebody said, are the molecules in gas visible with microscope? Um, Very good question. Very good question. Yes, yes. A microscope is used to view very tiny objects or maybe microorganisms, materials that cannot be seen with the naked eye. Are you with me? But the particles of gases, all right, because even though they exist, but you may not be able to see them. Sometimes you can even see them. You may not even need a microscope to see the particles of a gas. Let me give you an example. Your water, if you are boiling water and the water begins to move and turns to vapor because of increased temperature, all right, that's water vapor. If you open your pot that you are boiling, do you see water vapor? You see it. So you see the gas emanating. So you may not even need a microscope to confirm that. But you can, if you use a microscope, you'll be able to see it. It will magnify it, and you'll be able to see that the particles are bigger under a microscope to enlarge it. I hope that answers your question, Udubu. Any other question again? Any other question? Any other question? All right, so I don't want this video to be too long. So in the absence of question, I'm going to end this class now. This is 9:03. We are going to take one more topic. So as soon as I end this class, I will start the next class, and then you can connect just through this on the YouTube channel. I'm going to start it, but I don't want this video to be long, so we are ending the class now. All right, so see you in the next class.